This will be for the con assignment, estimating slope of line of best fit. Okay, you can read the write-up if you want, but in every case, you're basically just going to be finding the slope. Okay, and it looks like it's multiple choice. All right, so let's see here. Okay, so here we have our graph, and we just want to fit a line to the data. Okay, now I know you might not have a drawing tablet, so you might not be able to draw on the screen, but the bottom line is you can really just pick 2 points. Okay, I'm going to draw the line to make it more visual, but let's see. If I were to draw a line through these points, I would say it doesn't have to be exact because it's multiple choice and you can choose the closest one. Okay, so choosing those 2 points. All right, maybe I need to draw this a little thicker here. All right, roughly speaking. Doesn't have to be exact, like I said. Okay, and remember the formula for slope. It is the change in y over the change in x. Okay, that triangle is a Greek letter, delta. That just means change in. All right, and really, change in y is y2 minus y1, and change in x is x2 minus x1. Okay, so let's look at the change in y first. All right, we just look at our line and we get the y coordinates. All right, at the top of the line. And you know what? If I trace the line to the y-axis, it's here, but I would rather it be at 80,000. So let me just extend this line a tiny bit. Okay, and that might make it easier. All right, so change in y. Let's go to the y-axis. We start at the end of the line. And we're at 80,000. And the other y coordinate for our line, we go to the other end of the line right here. Okay, and we started at 0. All right, so it's just 80,000 minus 0. Okay, and now for the x coordinates. Again, go to the end of the line. Okay, and we'll trace it down to the x-axis this time. We are at 20. And the other x coordinate, here's our line. We go to the other end of the line, and the x coordinate is 8. So it's going to be 20 minus 8. Okay. Now, before I forget, when you draw this line, try to have the line end up on the corner of the boxes, okay? Because then it will make it easier to choose points. All right, and especially if you can make it on the corner that lines up with one of these numbers here, that would make it even easier. Okay, 80,000 minus 0, that's 80,000. 20 minus 8 is 12. And I will do this on the calculator, 80,000 over 12. Okay, and I got approximately 6,666. Okay, and actually the decimal kept going, but that's okay. We don't have to be that accurate. It's just an estimate. Okay, so let's see. So clearly out of our choices, the closest one is 7,000. Okay, so that's all you have to do. Just find the slope. All right, now let's see here. I want to show you that the 7,000 matches what they asked. Okay, they asked, which of the following is the estimate of the average change in a person's income that is associated with going to school for an additional year? Okay, so we said the slope was change in y over change in x. Okay, we can see the y-axis here is the income. So this is really, the slope is actually change in income, and the x-axis is years in education. Okay, so it's change in income divided by change in education. Okay, and we got a slope of 7,000, or close to that, which is the same as 7,000 over 1. So what that slope says is every time the education goes up by 1 year, the income goes up by 7,000. Okay, and that's basically what they asked. The average change in a person's income that is associated with going to school for an additional year. Okay, so again, you don't have to read the write-up. They're all about the slope. All right, so let's find the slope first. We have our dots here. We want to fit a line to these dots. Okay, try to choose points on the corner of the box. Try to choose points that match these numbers on the x and y axis. Okay, so if I were to draw a line through this, I'm going to say about right here. Okay, so let me draw this line here. Let me see. See if I can do this. All right, so there you go. Now we just find the slope using those 2 points. Okay. So that's going to be y2 minus y1 over x2 minus x1. All right, let's do the y's first. This is the y-axis right here. Okay, so we're starting at 7 for this point. And the bottom point, if we trace it to the y-axis, that's a 3. All right. And now for the change in x. All right, make sure you're subtracting the same way. So for the y, we started here, and then we did this one for the second point. So make sure you do the same thing for the x. See, the 7 was first, so that means I started here. I want to start here also for the x. Okay, so this point here, if we trace it down, we can see the x-coordinate is 0. Okay, and now go to the other end of your line. Right here, if we trace it down to the x-axis, that x-coordinate is 4.5. All right. So make sure you choose the points in the same order. Like I said, I know most don't have a drawing tablet. You don't really need to draw the line. Just pick points at the end of the imaginary line. Okay, 7 minus 3 is 4. 0 minus 4.5 is negative 4.5. Okay, and I don't think we need to get into fractions. If I had to guess, I am going to say this is approximately negative 1. All right, so let me see if I can find a slope of negative 1. Okay, and sure enough, you can see that answer C is negative 1. Okay, so if you were to do 4 over 4.5 as a fraction, that would be 4 over negative 4.5. That would be negative 8/9. Okay, we don't have anything as far as 8/9. You just choose the closest one. So that's negative 1. Okay, and just to show you the interpretation of that slope, they wanted the best estimate of the average change in mood associated with the 1 hour increase in hours online. Okay, so as we said, slope is change in y over change in x Y is the mood rating, and the x-axis is the hours online. So that's change in mood divided by change in hours online. Okay? And we got a slope of -1, which is the same as -1 over 1. Okay? You can put any number over 1, and it doesn't change the value. So since it's -1, the mood actually goes down when the hours spent online goes up. In fact, the mood goes down by 1 point every time the hours spent online goes up by 1. Okay, and that's what they asked. The average change in mood associated with a 1 hour increase online. The mood goes down by 1.